All right, so tonight we're focusing on solving equations. And we looked at one-step equations in class, and we're going to be seeing two-step equations and one-step equations tonight. So solving equations is different than simplifying. And when I say simplifying, we should be thinking of order of operations. So GEMDAS or PEMDAS. And that would be if we knew what a value was. Like instead of x plus 2, let's say we knew it was 1 plus 2, and we simplified by adding. Simplifying is the opposite of solving. So when we solve something, we're not going to do GEMDAS, we're going to actually do things in the reverse order. So inverse operations in reverse order. So we'll see some examples of what I mean by that. So let's take our first example here. So let's say you have 10 is equal to x over 4. So this is only a one-step equation. If we knew what x was, we would divide by 4. But we don't know what x is. We're solving for it. So we're going to do the opposite of that. Instead of dividing by 4, we're going to multiply by 4. So let's do that to both sides of our equation. These now cancel out, and we're left with x equals 40. And whenever you get an answer, double check your work. It doesn't take that much more time. 10 equals, instead of x over 4, let's plug in 40. Does that simplify? 40 divided by 4 equal 10? Yes. All right, so what if we had something like this? So let's say we had 5 is equal to negative x over 3. Well, I see that x is being divided by 3, so we're going to have to do the opposite, which is times 3. But I also have this negative here. So how can I get rid of a negative by multiplying? Well, let's multiply it by a negative 3, because a negative times a negative will become a positive. So that cancels out the negative and the 3. We're left with x on the right. Negative 3 times 5 is negative 15. And let's check our answer. So we have 5 is equal to x over 3 negative. 5 equals negative 15 over 3. 5 is equal to negative 15 divided by 3 is negative 5. And minus a negative, or a double negative, is just equal to positive. So yes, this checks out. For number 3, let's say we have 2 plus n is equal to negative 8. Well, if we knew what n was, the first thing we would do is we would add 2. But we don't know what n was. We're going to solve for it, so we have to do the inverse of that. We're going to subtract 2. Those become a zero pair. We're left with n equals negative 10. Let's check our answer. It can't hurt to take that extra 10 seconds to check. 2 plus negative 10. Does that equal negative 8? Yes. All right, next one here. So now we're on to 4. So one thing we didn't see in class today is what if you had a fraction times a variable is equal to another number. Let's say 8. Okay. So if we knew what x was, we would multiply by 4/5. We don't know what x is though, so we need to solve by doing the inverse operation, divide by 4/5. But dividing by a fraction isn't super nice looking. So we can actually do something different whenever you're multiplying by a fraction. If you are ever multiplying by a fraction, so multiplying by a fraction, you can solve by multiplying by the reciprocal. So a reciprocal is a really important vocabulary word. Hopefully we've heard about it before, but what it is just when you have a fraction, you just flip it. So instead of dividing by the actual fraction, we can multiply it by the reciprocal, the flipped version. So let's multiply both sides by 5 over 4. And the reason we do that is because these now cancel out. The 5s cancel, the 4 cancels. We're left with a 1, which identity property tells us 1 times x is just x. We now have 8 times 5, which is 40 over 4. Let's simplify that. X equals 10. Now, as always, I want to check my work, so I'm going to give myself a little space. And let's check our work. We have 4/5 times x, which we're going to say is 10, equals 8. 4/5 times 10 is 40 over 5. Does that equal 8? Yes. So our answer is correct. All right, let's move on to a two-step equation. So let's say we have 5x plus 1 is equal to 16. So what should we do first here? Well, if we knew what x was and we were simplifying, if we knew what it was, order of operations would tell us to multiply by 5 and then add 1. To solve, we're going to do the inverse operations of those and in the reverse order. So we look at the last operation, that adding 1, and we're going to do the opposite of that. We're going to subtract 1, and then we'll divide by 5. So subtract 1, 0 pair, 5x is equal to 15. Divide by 5, x is equal to 3. Let's double check our answer. So 5x plus 1 is equal to 16. Plug in 3 for x. 5 times 3 is 15 plus 1. Is that equal to 16? Yes. So our answer checks out. All right, what if we have something like this? b plus 3 divided by -7 is equal to 2. So a lot of times when we're solving equations, we're used to seeing them in this format where we frequently add or subtract first and then we multiply or divide. That does not mean that we always solve equations in that order though. It really depends on where our variable is and what we would need to do if we were simplifying it. So if we knew what b was, let's pretend we know what it is. The first thing we would do to simplify would be to actually add this 3 first. And then we would divide by -7. We would have to take care of this top part first before we could divide. So if we're going to solve, we do the reverse order inverse operations. So we're actually going to be looking at this divide by -7. We're going to do the opposite. We're going to multiply by -7, and then we'll subtract 3. So that'll look like this. We're going to multiply both sides by -7 because this is a big division symbol, and we have to get rid of it by doing the inverse of dividing, multiplying. So those cancel. We're left with b plus 3 is equal to -14. Now we can subtract both sides by 3. Cancel. b equals -17. Now that looks great, but let's just double check our answer. So we have -17 plus 3 divided by -7 is equal to 2. Let's simplify the top first. -17 plus 3 is -14 divided by -7. Does that equal 2? Yes. So our answer is right. All right, so that was number 6. Let's go on to number 7. Almost done. We got 7 and then 8 and we're done. So let's say you have 1 plus 2/3 x is equal to 10. All right, so if I knew what x was, I would be multiplying by 2/3, and then I would add 1 to it, if I knew what it was. But I'm going to solve because I don't know what it is, so we're going to do reverse order inverse operations. So instead of plus 1, we're going to subtract 1, and instead of times 2/3, I'm actually going to multiply by the reciprocal, because that's that times by a fraction, so times 3 halves. So we'll subtract 1, 0 pair. 2/3 x is equal to 9. And now we can multiply both sides by the reciprocal. Times 3 over 2 times 3 over 2. Those cancel. we're left with x is equal to 9 times 3 is 27 over 2. And I honestly wouldn't put this in a decimal. I could just leave my answer like this because it can't be reduced any further. So let's check our work. So we have 1 plus 2/3 times 27 over 2 equals 10. Multiply first. 2 times 27 is 54 over 6. Plus 1 is equal to 10. Let's simplify that. 1 plus 9 is equal to 10. Is that true? Yes. So our answer is correct. And last one, we have number 8. And I have 8 minus x equals 5. So looking at this, it really looks like this is only a one-step equation, but it's actually two. Because in front of this x, there is a coefficient there. It's a -1. We just don't usually see it written that way. So you don't have to write a -1, but I see it as there. So if we knew what x was, if we knew it, we would be multiplying by -1, and then we would be adding 8, because this is a positive 8 right here. This negative is a part of x, because it's -1x. So even though there's not a plus sign in front of 8, it's still being added to the variable. So to do the inverse operations, we would subtract 8, and then divide by -1. So let's subtract 8. That creates a zero pair. We're left with -1x is equal to -3. Divide by -1. Divide by -1 on both sides. X equals 3. Let's check our work. We have 8 minus positive 3 is equal to 5. Is that correct? Yes. All right, don't forget to complete the Google form. Have a great night.